All right, guys, in this video, it's pretty late, so I'm going to try to do my best not to fumble through. I'm very tired, and I'm going to just kind of make a couple of quick announcements, and then I'll jump into this video. And hopefully this will be helpful to people who are definitely trying to stay on top of understanding domain and range, which again is in Unit 2. So the first thing I want to show you very quickly, give me a second, the cursor's doing something weird here, is in Teams. Keep in mind that under the particular area, whatever your tab is, and I'll show you that in just a second if I can move this out the way. Okay, so if we go into Teams, guys, and let's just say, depending on the colored tile that you have, let me move this toolbar out the way. I don't care if it's the red tile, blue, green, purple, okay? Any tile I have already uploaded, and I'll just go into this purple one. This is the setup every time, right? So again, tonight, you know that by 10 o'clock, it's like 10 minutes till, and I am going to check the timestamps for who's late. But basically, this is where you find your homework assignments. You go to General, and then, of course, this toolbar is in the way still, but you go up here to Assignments, and that's where you find any of the assignments I want you to do electronically. Keep in mind, you guys, it's very challenging for me compared to other content areas to make it to where you can edit on top of stuff because, again, you know, math equations and math problems, most of the time we write them out on paper. So moving forward, the two things I'm going to try is soon I will have Nearpod. And with Nearpod, I'll see what its capabilities are to do math. But mainly, I'm probably going to do homework through Study Island moving forward so that you guys can have multiple choice and you can just click and everything. But I do need you writing out and practicing problems. So again, anything though that I do want you to edit or try to do through a worksheet or something I upload or a homework I make will be here in assignments, okay? Maybe after this weekend, moving forward, I'm debating. Under here where it says class notebook, I'm considering making a tab or a section where you can sit back and I upload all of my teacher notes, but I want to be clear that it's your responsibility to follow along and to bullet point and to take notes when you're in class with me or when I tell you and direct you to take notes. It's important that you write kind of, you know, in your own handwriting instead of me just posting answers and notes and then you don't do anything but just listen and then that makes you forget, right? So I'm considering possibly to give class notes at some point, maybe before exams or something. All right, so, and if there's any special files or anything or extra worksheets for practice, you can find them under here in the file section. Again, this is still in the general. Exit tickets, I have not utilized this just yet because I just put them in the chat box, but moving forward, I will put the exit tickets here, probably next week, just depends on my schedule. Extra credit assignments, of course, you can go here. If I give only one extra credit assignment, it's worth a lot. It gives you anywhere from 10, maybe even 12 points toward the actual test for the unit, and it'll be under files. So there's actually one already loaded here in the Unit 2 functions, but we'll talk about that later. So what I want to talk about now, really important, is remember how I said on Friday I'm doing a note check to see how many notes you were taking for class. So remember we took some notes today through the quizzes lesson. And you needed to bullet point about the vertical line test, right? But I also want to be clear that there are some other resources that I've uploaded here in this Mrs. Mosley YouTube channel. Right here in the post area or announcement area, there are 4 videos to help you, okay? You are more than welcome to watch these videos. And then when you watch these videos, take notes and watch and make sure you understand what they're saying. But mainly this video that you're watching right now, I want you to take notes over this particular video because I'm going to go through quite a few things. But you are more than welcome to throw in the Khan Academy videos and any of these other videos that you got something out of it. These are due Friday by midnight, okay? All right, so let's jump into it. So back to the document camera. Please know that I really try hard to teach in class, and it's a lot of thinking, okay? But I do these help videos to help you, and I'm noticing that some people don't watch them, and they're pretty helpful, I think, because again, I give a lot of problems away for your homework and even the additional practice worksheets that I upload. Okay, So that's that. Make sure that you watch this again so you understand where the videos are, where the resources are for your tile. All right, so let's go back over this right here, all right? This is about how to, let me give this a title, how to determine a function, okay? How to determine a function. And basically these things here, this is if you're given some kind of relation or ordered pair, so x comma y. So if you get some ordered pairs or coordinates, okay, this is the rules you want to follow. You also may be given a table of data, okay, so a table, of course, there's an x, which is our input, a y, which is our output, and then they give you, different kinds of coordinates. I'm just making some up. And then over here, they'll have some output values. So this is your independent variable. This is your dependent input, output. So let's just say, I just made up those numbers. So whether they give you actual coordinates or they give you a table, you have to be able to determine if it is a function, yes or no. And then today, don't forget, we talked about graphs. Remember, we've looked at two different types of graphs. We've looked at discrete graphs. Remember, discrete are the ones that just have a bunch of random points. Okay? And then they want you to say, hey, is this a function? Let me zoom in. I'm just kind of sketching. And then, of course, we have graphs that are continuous, which means, again, there are a bunch of points or dots connected together, and you see a line or an arrow. So again, let's just imagine they give us something like this. This one is continuous. And again, there's infinite points connected together. So just to be clear, you have to be able to determine if there is a function, yes or no, whether you get an ordered pair, a table, or different graphs, all right? And then, of course, we get into stating whether they give you a coordinate pair, or if they give you a table, or if they give you a graph. You have to also be able to determine what? The domain and the range to describe it and to state it. So that's what we've done so far, okay? So let's look real quick at, and I'm going to just rewrite these because I bet this is probably too much stuff at one time, is yes, you are a function. Yes, you are a function if you have one x for one specific y. So again, that means all your x's are different values in numbers, negative or positive, and all of your y values are different, okay? So look right here as an example, -3, 7, -4, 8, 5, 10, 6, 12. Notice all the x values are different. All of the y values are different. There is one specific x as an input, and your output is one specific y, and nobody else looks like, this relation or that relation and so forth. So this is a function, okay? Now, another way that you can say, yes, it's a function, is if you have two different x values. Again, I can't stress that enough, two different x values, and they're outputting the same y, okay? So again, that would be something like, 5, -6, and then we turn around and have 3, -6. So we have two different x coordinates, but we're getting out the same y. Okay? That is okay. And just so you know, something that would look like that, I don't know, would be like, let's just say I'm going to make this up. Okay? Notice how all of these points over here, let's just say the y value is like a 2. That's a 2. I made that up, okay? But notice that every single point that's on this function or this horizontal line, all the y values would be 2. And that would be, like I said, this could be, 1, positive 2, 2, positive 2, 5, positive 2. So all the x's are different, but the y is the same, and that is okay. And why is that okay, guys? Because guess what? If this was the function they gave me and I put a vertical line through it, it passes the vertical line test. Why? Because it goes through that function one time. So that's kind of where those two things come into play. All right, but what's a no-no? Okay, right here. No, it's not a function if, again, you have one x value, one input, and you get two different y values. Y values. Okay, So an example would be 1 minute they tell you, hey, it's -1 comma 4, and then you look again and you see -1 comma 6 or -1 comma -2. I'm going to do another one, -1 comma -2. Again, you have this input of -1, input of -1, input of -1, but unfortunately, what's wrong with that is you can't say it's 4 1 minute, it's 6 1 minute, and -2 another minute. So this is not a function, okay? So hope that makes sense. Also, let me just kind of sketch something. So let's say the function they gave us, thank you. Yeah, let's say the function they gave us is something like this. Okay, so if you notice, right, let's just say I tell you right here, x is 1, okay? And then again, up here, I tell you this point right here is like, I don't know, 1 comma 4. And then this point right here is 1 comma 1. And then down here, this would be like 1 comma -3. So you notice, right, that all of the x values are the same, but then again, you get all these different y values. That's a no-no, okay? And again, if I do the vertical line test, if I do a vertical line going through this function, you see it doesn't pass. And it doesn't pass because, again, it's going through there 3 different times. So it fails the vertical line test. So the vertical line test is just a fast way, right? Like, boom, put a vertical line, no or yes, okay? Other times, if you don't get a graph and you're given points, you have to think about it and you need to understand these 2 rules. So I hope that makes sense, okay? That's what I was trying to convey through last week and then on yesterday. I'm sorry, today. I'm very tired, sorry. All right, so let's jump into, we'll ease into this in a second. So there is a worksheet in the Unit 2 folder, and it's just there in blank. There are pieces of these even on the homework that's due actually tonight or tomorrow night on Tuesday. So be very careful that you understand how to do this. So we're going to zoom in and we're just going to jump around and do a couple, and then I'm going to move to the next worksheet. All right, so let's look at number 1. Okay. All right. So very carefully, you can do this 1 or 2 ways, okay? As you do math more and more and more, it gets easier to do it where the coordinates are horizontal like this. But just for the sake of just learning, let's stack them vertically so we can look at it a little bit better. So I'm going to go ahead and go here. Okay, so again, real quick. I'm sorry, my paper's all messed up. My kid came and terrorized. Okay, so these are the problems. And again, remember, we're trying to find the domain and range of each relation. I feel like this is one of the easiest things because all the answers are just like right there in front of us. Okay, so I'm going to zoom in. And again, if you cannot evaluate it by looking very carefully, you know, side by side and keeping straight, oh, look, I'm a 1, I'm a 2, 0, -1. As I say them out loud, okay, is I'm noticing that they're all different, right? 1, 2, 0, -1, there's 4, there's -1. So as soon as I see one that's I've said before, like -1 comma 3, and then look, I get -1, 5. That's a problem because what do my notes say? My notes say I cannot have 1x with 2 different y values. Okay, I cannot have, and that's the whole point of taking notes. So you take out worksheets that I give you to do for practice and for your understanding, you rewrite the notes over again, and then you sit back and have them right next to you, okay? So again, -1, 3, -1, 5. This is inconsistent. So in my mind, what I would have done is I would have circled these 2 to focus on, and then look right here, here's another one. 1 minute I input an x of 4, and I'm outputting -5. And then the next minute I put in 4 again, and I output -4. So this also is an issue. I cannot have 1x and then 2 different y's, all right? So again, This, I can already tell you, it's not a function. And I know that the directions you guys don't say, find the domain and range, and is this a function? But the fact that we're doing these things and these are the objectives, that's the way you want to study. Okay? And let me also, again, what I would have done too is you can stack them on top of each other. This is number 1 again. And again, I'm just noticing input, output, x, y, x, y, x, y. You see? Oh no, there's a -1, there's a -1. They're different y values. This is a no, and that's that. That's one thing to think about, even though they're asking for the domain and range, okay? Now, let me also, because I know on tomorrow, and if you're watching this video on Tuesday night, which is awesome, I just want to be clear. Basically what's happening is, this is like, I'm going to make this little thing called like a function machine, okay? So this is a function machine, all right? So I'm going to put this little denotation f of x, this function, all right? I'm going to input a value of x. I'm going to spit out a y value. And remember, my function could be something like, I don't know, 3x minus 7. Every time that I input this value of x, it could be a negative, a positive, a decimal, a fraction, doesn't matter. When I substitute it in to the function, this is the function machine, it's going to put that value right in here for x. That's what we're going to talk about on Tuesday. Once you put in that value of x, it gets multiplied by 3 in this case, and then 7 gets subtracted away, and it's going to output this y value. Also keep in mind that this denotation, f of x, is the same as the output. So when you see this denotation, whatever you do after you evaluate your function by plugging in your x value, this is the number that will come out y. So f of x is the same as like a y, the output. So I just want to be clear. The reason why I'm stressing this is that when you put in an x 1 minute, like -1, well, you said earlier that you're going to get out y would be 3. But then you turn around, you put a -1 back into this same machine. Why is it you're getting out a +5? You see? Or you put in a 4 into this function machine right here, and then 1 minute you get -5. And you turn around and you get -4. So that's what I'm trying to say, is that you cannot put in one x value and get out one y value, a different y, a different y. That's a no-no. All right, so that's just a visual if you can understand that. So again, number 1, the answer is no, not a function. I know that's not in the direction, okay? It was a no because of this. It was a no because of these guys, all right? Now, doing the domain and range, very simple, is we're just going to list, because I don't want to write on that worksheet. So for the domain, curly bracket, we're just going to start listing our x values. Matter of fact, I take that back. I can write on it because I'm not going to have y'all turn this in. This is for your practice and understanding. Okay, let's just write on it. Okay, so I'm going to say curly bracket 1, comma 2, comma 0, -1, 4. And then I don't have to write -1 again, guys, and I don't have to write 4 again. You're done. We don't have to write the duplicates. So now let's do our y values, the range, curly bracket, -1, -3, 5, just taking my time, 3, I have not written a +3, a -5, I have not wrote that, but when I get to this 5, I don't have to write it because it was over here, okay? And then over here, -4, I've not had a -4 as a y value. And that's it. So again, I know y'all know how to do domain and range. List the x values, all the x values. You don't have to write duplicates. List all the y values for the range. Okay, so let's jump to number 6. For number 6, real quick, I'm going to do the domain. So I'm going to just go ahead and circle all the x values. Again, those are the first coordinates. It's the first number in the parentheses. So curly bracket, I have a 5, a 3. I don't have to write this 5 again because I already have one written. Now I'm going to do 7, 13, 6. Okay, boom, done. Now, the ones I didn't circle are my y's. So curly bracket here, 5, 8, 4, 5, 8, 4. And then I don't have to write 5 again because I already have a 5. Okay, be really careful. Then I have 8, and then I have 2. Oh, I'm sorry, I don't have to write 8 again. It's already here. So we just have to write the 2. Now we're done. Domain and range. Now, question becomes, is this a function? So I'm going to go here. Again, you do not have to do this, but I like to stack them on top of each other. Okay, so I notice, oh, look, I input a 5 for the x. I get out a 5 for the y. 3, 8. And now, see, my mind starts to tell me what's happening right here. I plug in a 5, I get a 4. But then earlier I plugged in a 5, I get a 5, 5, 4. This is a problem. So this is not a function, okay? Now check this out though. 3, 8. Here's another number I see, 13, 8. See, this is okay. 2 different x values, same y. See, that's okay. All right? That's okay. Matter of fact, I just realized, see how tired I am? I meant to circle this one. Sorry, guys. No. I understand. No, I did it right. Because, you know, this is okay too. This one right here. See how this is 7, 5. See how this is a different x value from this one? They're different. And then they got the same y, just like this one. This is a different x from this one, same y. See, that's okay. What's not okay is this part, that I have the same x value, different y's. This is a great problem, actually. Everybody put a star by number 6, okay? But again, the reason why it's wrong is because of these two, okay? Not because of these two, because it is okay to have different x's, same y. It's not okay, again, one more time, to have same x, different y's. So this is a no, it's not a function. So I hope that makes sense to you. So you should be able to do all of these ones 1 through 8 for practice or whatever, even if it's not for a grade. But you know what? Maybe if you did it and you showed me you did it, maybe I go, you know what? Here's some extra points, okay? Now let's get to the bottom of this. Find the domain and range of the ordered pairs represented on the graph. So keep in mind, numbers 9, 10, and 11, guys, these are what kind of graphs? Discrete. So I would have told myself right here, they're discrete. What makes them discrete graphs is because the points are not connected. They're all scattered around the page. So this is a discrete graph, and you have to be able to do what? Give the domain and range, and then also tell if it's a function. So when I look here at number 9, I'll zoom in. Okay. What I'm looking for is only one thing. Listen very carefully. I know you know how to do the domain and range. You're just going to take your time and you're going to say, hey, look, this is -4. So I went again 4 to the left and I went down 1, 2, 3, 4, 5. So this coordinate here, just list it. -4, comma, -5. This one right here is -2, -4. Okay, you guys should be able to really key on how to do coordinates really fast, okay? But take your time at the same time if you need to. This again is -2, -4. This point here, I was at 0, 0. Where did I go? I went to the left 3 jumps. I went nowhere up or down, so I'm just sitting there at -3, comma, 0. Okay, this one right here is -4 for the x, and then the y is a 2. So as you can see, you could basically just list all of the coordinates on here. I'll do the last few. This one is 2 to the right, and I went 4 down. So this is +2, -4. Remember that the x goes first, the y goes second. I go back to 0, 0. Where do I want to go? I want to go here. So what am I going to do? Jump over 1, 2 to the right, and then 1, 2 up. This is 2, comma, 2. And then this one right here, I went 4 to the right and 2 up. This is 4, comma, 2. All right. So now that we have all those coordinates, all we would do is start listing the domain, right? We would say -4, -2. We don't have to write a -4 again. -3 is not there. 2, we write that one time. And then 4, we write it one time. That's easy. List the x's and y's. Now, question is this a function? Is this a function? Let this there. Hopefully that's super clear now. Let's go in some more. Okay, now what I need you to see is that even though these are discrete points, guys, if you put a vertical line, okay, through some of these points, you can see this, all right? Now, two things. You are more than welcome to list these out, which I can do that for you, okay? You can just list these points real quick. -4, 2, -3, 0, 2, 2, 4, 2, 2, -4, -4, -5. I'll get on the paper and just right there. Who am I missing? Oh, I missed -2, -4. And then I think that's everybody. There was one here. 1, 2, 3, 4, 5, 6, 7. Okay, I did good, and I'm half asleep. Here we go. Again, what I'm noticing is I input -4, I get out 2. I input -3, I get out 0. I'm still happy here, okay? Oh, I plug in a different x, 2, 2. That's okay. Now, what I'm focused on is, oh, I said 2, 2, -4, 2. Is this okay? Sure it is. I have an x value of 2, x value of -4. I have two different x's, same y. So I'm still good for a yes, okay? Now, let's get to this one. 4, 2. This is still okay because guess what? Different x's, same y's. Still okay. Now, what's not okay is right here, guys. This one. You see? And you know what I think gets some of you guys just saying? -4, oh, miss, this is a +4. Well, what happens when that one's negative and this was positive? That's okay, guys. They're just at different locations. Don't get caught up in like, well, Miss Mosley, I see 2 4s. One's negative, one positive. Yeah, they're at 2 different locations. But again, I'm focused on 2, -4, 2, 2. This is a no-no. You cannot have the same x, okay, same x and different y's. That's a no-no, okay? Now, also look at this one. You told me earlier -4, 2. Then you turn around and said, oh, when I plug in -4 into my function, I'm getting out -5. Inconsistent. So I'm just telling you that even this one right here and this one right here, that's a no-no. All right? So guys, this one is not a function. Okay? It's a no. Now let me also say very quickly, another way visually you can do it without, examining the ordered pairs, which you should examine the ordered pairs. Okay? If you see 2 dots, 2 discrete dots, and if I put a vertical line like this, you see how they go through? You see? I could put a vertical line through this point. It would have been okay. Through this one, a vertical line, okay, right? But look, even here, there's a problem. See, when you do discrete points, you have to put a lot of vertical lines because it's not continuous and connected. So you see, it fails because, again, I have the same x, different y's. Okay, again, same x, -4, different y's. So this one fails. This one, though, you don't see any points on top of each other. You see how there's one there, they're spaced out here, here, and here? Yes, this is a function. So yes on this one. And again, I know what you're thinking. Ms. Mosley, you didn't tell us to do that. But the point is, when you sit back and you're doing something in school in general, you have to say, well, what are we going over right now in school? How should I be studying? What are the things I need to know at this point? And at this point, you should be able to, again, give the domain and range, but also determine functions using all kinds of tables, ordered pairs, or graphs. Okay, I go here. Look, they're stacked on top of each other. So it fails the vertical line test. And again, this is a no-no. I cannot put in -6, get out +9, and then turn around, put it in again, and get out -12. So this one fails. No, not a function. Also, look right there. Fails again and fails again. So I hope this makes sense to you for discrete. This video is we're at 30 minutes. We're okay. All right, tables. Same thing, guys. You look carefully at the table, inputs and outputs, and you say if it is a function or if it's not a function. You know how to list the domain and the range because guess what you're going to do? curly bracket, put all of these x's. Don't write duplicates. Range, put all of these y values. No duplicates, so you only have to write -5 one time. I hope that makes sense. All right, so the question becomes, is this a function? Well, I input -17, I get out -5. I put in -13, I get out 6. I put in -9, put out that, put in -3, get out 13. So I'm liking this. All my x's are different, guys. All my x's are different. It does not matter that I have duplicate y's, because again, my x's are different. I could have the same y. Yes, this is a function number 3. All right, hopefully that makes sense. Let's find one that's a no. Look at this one. Look at number 6. Look how I have what? All different x's, all different x's, same y. This is a yes. I'm trying to find a no. I'm trying to find a no. I actually don't see any of these that are no, because if you look at it carefully on the worksheet, see, all the x's are different. All the x's are different. This one too, see? All the x's are different. So if they're all different x's, then, okay. So that takes care of that domain and range. For tables, guys, that takes care of it for ordered pairs, okay? And you saying yes or no. All right, last thing real quick. Last thing. You just watch this in pieces. Give me a second here. I need to get my... Okay, guys, so this will be the last part of the video. Hopefully I can get this done in like 10 minutes. So I need everyone to really hear me out when I do this part here. Let me get some more room. Okay, here we go. So how to sit back and find the domain and range on a continuous function. So again, remember, we have to be able to do it from ordered pairs, give the domain and range, tell if we have a function, how to sit back and do the domain and range on a table, and then also say if it's a function, and then how to look at discrete points on the graph and continuous. Okay, so these are all continuous graphs because again, we have solid lines, okay, we have curves, circles, we have Z's, zigzags, everything, okay, and it's continuous. There are infinite, lots of points that make up these solid lines. All right, so if we look at the first one, A, okay, what I'm going to do is I'm going to use a yellow highlighter to show what the X value is doing, and then I'm going to use a blue highlighter to show what the Y or range values are doing. So again, yellow for the X domain and blue for the Y range. All right, so the first thing I'm looking at is I go over here furthest to the left, and I say, hey, what is this coordinate? So I tell myself, okay, to get over there, I have to go 1, 2, 3, 4, 5, 6 to the left. So this is -6. Sorry, -6, comma. And then after I go -6 to the left, I'm going 1, 2, 3, 4 up. And when we move upward on the y-axis, we're a positive. So this is +4. So I got -6, 4. Then I come all the way over, because again, I'm thinking about x. And where does x have to do with? He's like on the number line, right? He's this horizontal axis. So I go over here to the right and I say, hey, what's this point right here? What's the x coordinate of this point? So I go, okay, I go 1, 2, 3, 4, 5, 6, +6 for the x component. And then how many did I go up? 1, 2, 3. So 6, 3. All right, so now what's so interesting, that's it, right? Again, this is where I start here, and that's why, again, I was always putting those boundary lines. And then over here to the right, I go through here. So when I look at x, I'm looking from left to right. So what are my x values doing? Well, basically, they're increasing, right, toward +6. So there are all these points that make up this line, excuse me, or this function. They're basically being what? Greater, because I'm moving to the right. So they're basically greater than -6 but they're less than positive 6. Okay, and just so you understand, you could go get the coordinate of these other points. So like this one right here is 1, 2, this is negative 3, comma 2. Negative 3, comma 2. This one right here is at 1, 2, 3, 4, 0, comma 5. And this one right here is at 3, comma 0. So when I compare, like, hey, I'm negative 6, hey, I'm negative 3. Well, guess what? I'm increasing. I'm getting bigger. Then I go to 0. 0 is bigger than negative 3. And then look, 0 compared to 3 is bigger than 0, and then 6 is bigger than 3. So the only thing that I can say is like, hey, look at my x values. They're basically being bigger as I move this way than negative 6, but they're less if I move that way, right? So the way we do the domain, D for domain, is we're going to say x is greater than and equal to, because there's a solid dot, negative 6, but x is less than or equal to 6. So basically my x values is everything between negative 6 and positive 6. All right, and it's equal to those values. So I hope that makes sense. Now, if I use the highlighter, here's another method, okay, is again, I'm just looking at the x components of these points and thinking about it. I'm between negative 6 and 6. Or what you could do is you could say, you know what, look, I have a solid, include negative 6, and all these values, so I'm going to just make a line, and I stop right under the function here. You see? So if you zoom in and you look at that, okay, I'm saying that everybody that is bigger than negative 6 but less than 6 is happening on the x-axis. All right? So I hope that makes sense. And the reason why I wasn't able to show this on today is because you guys don't have this sheet. And I didn't want to just be want lecturing. I wanted to visually let you guys see some stuff. But I will post this, okay? Now, that's the domain. Again, we are greater than negative 6, but less than positive 6 and equal to. All right, let's talk about the y, the range. So when we look at the range, we look from the bottom up. So that means that the lowest point is right here, and the y component on this point here is a 0. I hope everybody can see that. Now, the greatest point as we move up, the highest is a 5. So that means that my y values, when you look across this whole function from the bottom up to the top, it's 0 and 5. All my values are between 0 and 5. Again, there's numbers over here that have to do with decimals. There's other numbers here with decimals and whole numbers. Okay? But again, my lowest y value is 0. The greatest is 5. So the range is going to be, and we're talking about y, so we're going to say 0 is less than or equal to y, meaning, again, read it this way. Y is greater than and equal to 0, but y is less than and equal to positive 5. Okay? And so, again, understand that, because all I do is I do the lowest to the highest, and I'm just focusing on the y value. Okay? When I look from left to right, I'm looking at the one furthest to the left. Cover up the y, there's a negative 6, there's a positive 6. All my function falls between there. Okay, I hope that makes sense. So I'm going to use the highlighter method now. So I go to the y-axis and I say, hey, what's my lowest point? So I'm going to put a solid dot at 0 for the y value, and y is on this vertical axis, right? So what's the greatest value? Well, if I put a dot right here, I'm saying that every value of y is being described in this function between 0 and 5. So that's the other way to do it, okay? So I'm going to jump around and do 2 more, and then I'll stop there. All right, let's look at this one right here. Okay, so what's interesting about this is all the x values, you guys look at it, it's the same. You know, if I look at all the infinite points that make up this solid line, all the infinite points that make up this solid line, all the x values are the same, okay? So if I choose a point like, let's say right here, this is 0, I move to get to this function, this line, I went to -1, -2, -3, -4. See? -5 for x. And all of the points that go through this particular x value, x is equal to -5. Okay? You don't see x at -7. You don't see a point, for this function over here at x equals 0. You just see it when x is equal to -5. So that's the domain. The domain, we're just going to say x equals -5. How easy is that? Okay, this is a solid line going through -5. All right. For the range, it's going to be trickier. So notice that I didn't have to do anything with the yellow because guess what? Okay, and I want to be clear. I'm not doing anything left and right. I'm just doing right there a solid dot at -5. Okay, let's talk about y. For my y values, though, they're changing. And I'll describe this to you like this. If I say, hey, what's the coordinate of this point? Well, this point is, again, x equal -5. But my y value is, look right here, 1, 2, 3, 4, 5. So this is -5, comma, +5. -5, comma, +5. If I put another dot on here, let's just say right here, this is again 1, 2, 3, 4, -5, and then I went up 1, 2. So this point is -5, comma, 2. And then as I do some more dots, I just start looking and making a comparison. Here's one more down here. See, the x value is still -5, but I'm down at -1. So this is -5, -1. So what's happening with my y value? I know the x values are staying the same, but my y values are basically, now what's this one up here? This is a +6, this open circle right here. So this is right there, -5, comma, 6 is the greatest value is 6, but guess what? You're not equal to it because it's an open circle for y. All right? And then here, the lowest value, if you look on the y-axis for y, -1, -2, and I want to say that's pretty perfect right there. So this is -5, -2. So when I compare my y values, I'm going to get this blue line. And again, all right, sorry guys. So again, I'm coming to the y-axis. So I'm saying there's an open circle here at -2. And all the values of y are happening all the way up to +6 and then open circle. So you see all my y values, and I'm going on the y-axis, you guys, because it's making a comparison. Because when you read your y values, you read them off of this axis, okay? That's why I'm coming over here, even though the function is over there, if that makes sense. All right, so here we go. So we're going to put y. And what are my y values? Well, they're greater than -2. I'm only looking at the y component, the y's, the range. You see? So I am greater than -2, not greater than and equal to, because I don't include -2. But my y values are equal to, look, -1. My y value can be a 0. My y value could be a 1, a 2, a 3, a 4, and decimals in between. So y is greater than -2, but not equal to it. And y is less than 6, but not equal to it. Sorry for my handwriting. So guys, again, it's -2 is less than whatever values of y, and then y values have to be less than 6. Let's do another one. We've done this one quite a bit, okay, so I'm not going to do that one. I did this one in tutorials. We'll talk about this one. So same thing. This one is not a vertical line, but a horizontal line. So notice that all the y values are equal. 0, 4 is right here. I put a dot here, and this is 3, 4. Trust me on that. Look, 1, 2, 3, and then I went up 1, 2, 3, 4. This is 3, 4, and then I kept going and I ended up at 7, 4. So what are you noticing? All the y values are equal to 4 because I'm going through what? 4 on the y-axis. So your range is y equals 4, period. There's no other value for y being described on this solid line. Every y value on here is a 4. Now, when I look at my x, though, and remember for the x-axis, we look at the number line. So I said, hey, open circle on the x-axis at 0, right here at 0, open circle. That's an open circle, trust me. It's just a big highlighter. And then I noticed that my x values are increasing because I'm going where? To the right, towards positive infinity. So when I start shading that I'm going on forever and ever this way, the only thing I could say about the x values right here is I say they're what? They're greater than 0. All my x values on this function, you're comparing it onto the x-axis. All my x values on this solid line are doing what? They're increasing, getting bigger than 0, but not equal to because there's an open circle. So I hope that one makes sense. All right. Okay, let's look at this one. I'm going to do one or two more, and then that's it. Okay, so for this one, pretty straightforward, is when I go the furthest, again, it's a rectangle, okay? When I go and look at this function furthest over to the left for my x values, I'm at -3 because you're at 0, there's -1, -2. Look, x is equal to -3. And all of these points that make up this solid line, guys, all these little points, little dots are making up that solid line. X is at -3. Okay, so let's get the coordinate. Like this one is at -3, comma, -2. This one up here, the x is still the same at -3, but my y value is 1, 2, 3, +4. So this is -3, +4. All right, and then I'll come over to the furthest to the right. My function ends over here on the right, even though it's this rectangle. It's 1, 2, 3, 4. And then what's this point here? 4, comma, -2. And this one is 4, comma, 4. So now when you sit back and you look from left to right, so notice I'm going to go on the x-axis with the yellow, and I realize everything is solid. So I say, hey, it's solid through x right here. It's equal to -3, and all the all the x values are heading over towards +4, and it's equal to that. So all of my x values that are described for all of these points, you see, the x value is greater than -3, but less than 4. All right, I hope that makes sense. So the domain for this one, I'm going to put it on this side. Domain, I'm just putting a D. X is greater than and equal to. All the x's are bigger than -3 and equal to -3 because they're equal to -3 here. But x is less than 4. There's no x equal 5, x equal 10 over here. It stops x equal 4. So x has to be less than and equal to 4. And again, this is a -3. I think that looks terrible. -3, less than or equal to x, less than or equal to 4. Here, I wrote it better. All right, that's what x is doing. Now let's look up and down. So now we say, hey, look at this right here. My y values looking from the bottom upward, all my y values are equal to what? -2. So I'm going to put a solid dot on the y-axis at -2. And I notice that, look, when you do these sides of this rectangle, you see y can be all of these values here. But y has to be what? Less than or equal to +4. I top off on my range, my y value is at 4. So the range is going to be, you're talking about y, so you're going to say y in the middle, my y values are greater than -2 and equal to it, but less than and equal to 4. And that's that, guys. Okay, so I hope that makes sense. I'm going to do this one super fast. Notice how this line has no boundaries. It has no points. It has no open circle. It's not a segment. See, it's not a little piece. That's what I was trying to say today. It's not little segments. It's this long continuous function going on forever and ever. And if I extend it off the page, just so you can see, you see, your x can be anything. See, if you look this way, see, your x is going to negative infinity, on and on and on and on. If you look this way to the right, your x values, see, I'm referring to the x-axis when I do that. See, this could be 10. See, there's an x equal 10. If I go over here, this x over here could be a 20. So I'm going to positive infinity, and then this way I'm going to negative infinity, and the way we write that is all real numbers. So the domain for the x values is going in both directions, so all real numbers. All real numbers, or again, negative infinity to positive infinity. Now, when I talk about y, the same thing is happening. Watch my pen. If I look from the bottom, because look how that's going on and on and on. If I look from the bottom, moving upward on the y-axis, what's happening to my function? It's going on and on and on. It's increasing that way. At the same time, it's simultaneously decreasing this way. So my y values, my range, is being described everywhere. Y can be anything. So it's the same thing. For the range, all real numbers. All right, guys. That's just stick a fork in me. I'm done. Okay. Please watch this video. I hope this makes more sense to you. I will upload this sheet for your reference. There's even some on this side. So again, what I would do, and I'm willing to give some bonus points. Okay, our test is September the 28th, so we still have like another 2 weeks or so, but I may do a little intermittent, an in-between quiz just to see where we are in our understanding, but I will upload this, and maybe if someone fills this out, and you're able to tell me why you got what you got, or you give it, I may just do some bonus points on this, but please, 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 please do not hesitate to ask me about this stuff. Okay, guys? All right, I'll see y'all on tomorrow, Tuesday, September the 15th. Have a good night.